I think we should work on mixtures because that's going to be on my final, and I don't know how to do them at all.
I'll let you direct. You just tell me what kind of problems you want to work on, and if you can verbalize them, we'll do problems.
You know what I mean when I say mixture problems?
Not sure.
Okay, one sec. Let me pull some up. Okay, so wait. This is just showing me how to do them. Right, that's not what I want. Mixture problems. Fix that.
I assume you meant a mixture of disciplines. But it doesn't really matter to me whether you're doing a mixture of disciplines or not. If you can find a problem, read it, and we'll solve it.
Okay, so this might be an easy one, but I'm not sure. How many liters of a 70% alcohol solution must be added to 50 liters of a 40% alcohol solution to produce a 50% alcohol solution?
Okay. How many liters are we starting with of a 40% alcohol?
It doesn't. How many? Oh, 50.
Okay, so there's 50 liters of that. And we have a 70% alcohol solution that we're going to add to this in order to make it a 50% solution?
Yes.
Okay. The way I like to treat all of this is let's find out how much alcohol is in that. Well, 0.4 times 50. So there is 20 liters of alcohol, pure alcohol, in that solution out of 50. Okay?
Okay.
We want to add 70% alcohol. So let me think for a moment. What do we got? We've got... I want there to be 20 liters of alcohol plus 0.7 times X, the amount we're going to add. And all of that let's see, we're going to add X liters. So we're going to have, this needs to be 1/2 X. If X is the number of liters of alcohol that we add, or rather the number of liters of that mixture, then we will end up with 50 plus X. Let me think for a moment. We started with fixed 50. We're going to add X, and half of that needs to be alcohol. So, let me think about this for a second. Maybe I'm having trouble coming up with the equation, but I know I can do it if I do it on a kind of a trial and error basis. Maybe that'll help me come up with the equation. So, if I added 50 liters, okay?
Okay.
How much alcohol would I
add? You'd have 35, right? 35.
Okay. So the total alcohol I would have would be 35 plus 20. That would be 55. and the total volume I would have would be 100 liters. So if I added 50 liters, I would create a 55% solution.
Right. But it needs to be less than that.
Right. Now, let's see how I did that. I did that by taking 20 plus 0.7 times x. That has to equal, that's the amount of alcohol I have.
Right.
That has to equal 1/2 times the amount of volume of liquid I have, which is 50 plus x. There's the formula, I believe. Let's see.
Why is it over 100 liters?
I don't need that.
Okay.
I got the amount of alcohol I have, which is this 20 liters plus 0.7 times however much liters of fluid that I add. So this will be the amount of alcohol. And we need that to be half of the total amount of fluid that I have.
Okay.
So I can solve this equation now. And let's see, what do I got? I've got 40 plus 1.4x equals 50 plus x. So 0.4x equals 10. X equals 25. Now, does that work? In other words, that's how much 70% solution I need to add. Okay, let's see if that works. If I add 25 liters of this, I will be adding 15 liters of pure alcohol. So I will have a total of 20 pure alcohol from the original solution plus 15, so I will have 35 liters of alcohol, and I will have 75 liters of fluid. Why am I off by 5? No, let's see. This number is not 35. 7 times 25 is 17.5. So this is 37.5 is what I will have. And that is a 50% solution. So this equation is correct here.
Okay.
Might have gotten there a shorter way, but I don't think so. I think, yeah, these kind of problems, I think it definitely helps it if you treat the 40% solution of alcohol like it's salt. So there are 20 liters of salt in that mixture.
Right.
All right, and then go from there. So, all right.
Yeah.
What else do you have?
Okay. Let's see. So I have trouble factoring when there's a coefficient in front of, like factoring quadratics when there's a coefficient in front of the x squared.
Give me one. I think I can help you a little bit.
8x squared plus 10x plus 3.
Okay. Really involves a trial and error process. Okay. First of all, I cannot factor out a greatest common factor. That's what I would look to do to get this as small as I can get it. Well, right. there is none. So now I'm going to put it through my process. First thing is to split that up. Well, I generally tell everybody to choose the factors that are closest together. 4 and 2 are closer together than 8 and 1.
Right.
Now my signs are what? What do both signs have to be?
Positive, plus.
Okay, plus, plus. and I've only got two factors of 3, 3 and 1. So either this works, which it does, or if that didn't work, I would do it this way and see if that works. Oops, I'm sorry. I would do it this way. That does not work. That gives you 14 as a middle term. Okay?
But then what about 10?
Right, but if I put a 3 here and a 1 there, my middle term always comes from the insides and the outsides. The insides multiply to 6x, the outsides multiply to 4x, add those together, you get your middle term.
Oh, okay.
Okay? And
I was taught that it has to multiply to your middle term and add to your last term.
no, that's true if this coefficient is 1. But if anything but 1, you cannot use that method.
Okay.
In other words, you can start these with those first two steps, separating your x squareds and determining both signs. But after that, it's all trial and error.
Okay.
I can't say factors of 3 that add to 10. I could say that if it was that way, but not when there's a number there. It's definitely a degree of difficulty harder when there's a number other than 1 in front of the x squared. If there's just a 1 in front of the x squared, it's either a 3 or a 4-step process, same all the time. If they put numbers in there, especially if they're numbers that have more than one set of factors, because our answer could have been 8x and x, and I'd still be sitting here trying to solve it.
Right.
So
I mean, it's kind of just about plugging things in based on factors.
Right, and using that little trick that always use the as your beginning point, always use the two factors closest together. And that goes true even for these kind of factors. In other words, if I had, say, a 12 there, well, I would start with 4 and 3 as my factors. And if that didn't work, then I'd go to 6 and 2. And if that didn't work, I'd go to 12 and 1.
Well, let's say it was 12, so then you could pull out a 2 from everything, right?
Right. I could actually do that, yeah. In other words, the problem becomes this. And now the only part I have to worry about is that.
Right. Okay.
Do you have another one like that?
There's not another one in here, but let's try,
You could probably look one up in my book if you like. The problem is my book doesn't tell me whether it's factorable or not. So you can spend a lot of time trying to factor it before you come to the conclusion that I got to use the quadratic formula.
Right.
You know what I mean?
Yeah. So do you want me to give you one, or do you want...
Well, if you have one, yeah, go ahead, and then we'll go through that process again.
Okay, let's try 4x squared plus 2x plus 2.
Okay, now did you just make that up?
Yeah.
Okay. The problem with making up one is it won't necessarily factor.
Oh, right.
In other words, it's gotta be the result of the two linear products. So, first of all, if this was the problem, I would factor a 2 out immediately.
Right.
And then I would deal with what's left over. And what's left over does not factor. In other words, notice what I have. Well,
right.
This is never going to produce a. This has to be plus 1 plus 1. There are no other choices. This has to be 2x, and that's x. And that does not produce a middle term of plus x.
Right.
And there's no other way for me to factor that. So if this was indeed the problem, the moment I get to that, I'm going to the quadratic formula to solve that part of it. And of course, if I'm going to use the quadratic formula, I could always go back and start from that and not even worry about taking out a greatest common factor.
Right. it doesn't even matter at that
Does
point.
not matter for the answer you're going to get when you use the quadratic formula. It just makes it easier to factor the smaller those numbers are, if you're factoring
Right.
the traditional way.
So I got this question wrong too.
Okay.
This is a domain question.
Uh-huh.
1 over the square root of x to the fourth minus x to the
Is it the square root of x to the fourth?
minus x squared, all in the root.
Okay. Notice, hold on a moment. The way we're going to solve this is, what can the bottom not be? What has to be true about this quantity, the stuff that's inside the radical sign? Can it be negative?
Inside the radical sign? No.
Can it be 0?
Yes.
No, because if it were 0, then we'd be dividing by 0.
Oh, right.
So in this case, this quantity has to be greater than 0. And now I'm going to solve that inequality problem.
But isn't anything greater than 0 when it's like, isn't in this case, because they're being set to a even power, doesn't that automatically make them greater than 0?
Well, no, because if I had a fraction, in other words, if x was 1/2, this is going to be negative. This will be a positive number, and this will be a positive number, but this will be a bigger positive number than this. So you'd end up negative.
Okay.
Okay.
Well,
so the thing is, whenever you have a problem like this, just take whatever is in the radical and set it either greater than 0 or greater than or equal to. In other words, if this was in the numerator, then it could be 0. So
right.
I would set it to greater than or equal to 0. But being positioned where it's at, I know that that denominator has to be positive. It can't be negative, and it can't be 0. So now all I have to do is solve that. Okay. Well, that let me think for a second. Proper way to solve this. Notice that that's the difference of squares. Okay. And now my critical points are whatever makes this 0 and whatever makes that 0. Well,
whatever makes that one 0. Wouldn't that be 1?
No.
1 and negative.
Yeah. No, this one isn't 0, but you're right. A critical point is, there's a couple of critical points. And thank you. One of the critical points is 1, because this
and the other one's
-1.
-1.
And the other is -1, and the other is 0. There's 3 critical points. Is that it?
Okay.
Let's see. No, -1 is not. At least it's not over here.
Why not? Because if you
Well,
square
it is.
negative...
It is. You get 1 minus 1, so this becomes 0, yeah.
Right.
That should be it. Only 1s and 0s. I don't see any whole number not going to equal 0. So now what you do, once you've discovered the critical points, is you plot a graph of those critical points, and you do a line chart. And you start checking to the right and left. In other words, if I check this region, then I want to plug in a number that's to the left of -1. Well, let's try -2. Okay? When I plug in -2, this is positive, this one. And when I plug in -2 here, I get 4 - 2, so that's positive. So what that means is everything in this area is positive.
Right.
Now let's try a number in between 0 and -1. Let's try -1/2. Well, when I put in -1/2, this is still positive. And this -1/2, this becomes 1/4 -1/2, that's negative. So this area is negative.
Okay.
When I put in +1/2, in other words, a number in this region, well, this is plus, but this becomes negative, because +1/2 squared is 1/4, -1/2, that's negative. So it's also negative in that region. And finally, if I put in a number greater than 1, that's positive, that's positive. So my solution is, and do you use interval notation?
Yeah.
So my solution is -infinity to -1 with a parenthesis,
unison,
with +1,
infinity.
positive infinity. So there's my interval for my domain. In other words, I cannot have any number between there, otherwise it produces, notice that 0 would give me 0 down here, and any number in this area produces a negative number.
Right.
This is kind of interesting because I had a student tell me once that one of their teachers said that in these line charts, it's always going to alternate. And it doesn't, does it? I didn't think he was true when he told it to me, but I couldn't find an example that.
Wait, what do you mean it's always going to alternate?
Well, the student tried to tell me that when you break up your line chart into your critical points, once you determine that that's plus, then I could say, well, that must be minus, that must be plus, and that must be minus. But it's not true. It doesn't alternate. This one didn't alternate. We went plus, minus, minus, plus. Okay. What other? You have another domain?
That was the only one that was given to me on the test.
Let's say that this was the problem. Let me just real quickly make my point. Let's say I had that. Well, the way I'm going to solve that is to take that quantity and make it greater than 0. And then try to solve that. With this particular function, that wouldn't be that easy to do. But I mean, it's a cubic. Let's make it a quadratic. Okay. If I had a quadratic, in other words, my point is that no matter how complicated this function is, I'm going to solve the domain issues by saying that whatever is in there has to be greater than 0, and then solve it.
That only applies if it's in the denominator.
Yeah. If the function was this in the numerator, then I'm going to take whatever's inside there and make it greater than or equal to 0. Because now I could have 0.
Right. But when it's in the denominator, it has to be greater than 0 because it's in a square, because it's being rooted.
Well, well, the square root of 0 is 0, and you can't divide by 0. So if it's in the denominator, I can't have this being 0.
Right.
Then I
would couldn't you have it being less than 0?
No, because it's the square root, and square roots are always positive. You never get a negative. You cannot take the square root of a negative number. So even if my function was this, my domain is x greater than or equal to 0.
Right, okay.
Okay. Some functions are more restrictive. What's the domain of that function?
Greater than 0?
Yes. X has to be greater than 0. It cannot even be 0. You cannot take the log of 0. Any kind of log. You cannot take the log of 0.
Okay.
So the log function is more restrictive than the square root function. What's the domain here? Cube root of x.
Still, it's got to be greater than or equal to 0.
No, it doesn't. All reals. You can take you can take the cube root of a negative number. If I take the cube root of negative,
any odd root.
What's that?
If it's an odd root, you can take it of a negative number.
Right. In other words, if I want to take the cube root of negative 8, that's equal to negative 2. If I want to take the cube root of positive 8, that's equal to positive 2. There's no plus or minus.
But if it was the square root...
Whereas, if I'm taking the square root of 4, it's plus or minus 2.
Right.
So you can take odd roots of all numbers.
Okay.
Although if I had something like this, now x can be anything except 0.
X can be anything except... Right, because it's in a denominator.
Right.
Okay.
That's always the first restriction you want to think about, is you cannot divide by 0. Second restriction is you can't take square roots of negative numbers. Things like that. Domain is usually all about figuring out what it cannot be. Not what it can be, but what it cannot be.
Okay. So there was another one. I got it right, but I think... Let me just see if I got it right in the right way.
Okay.
So a man is 2 meters tall.
Okay.
And he is standing 4 feet from he's standing 4 feet from a tree to his right. Yeah, like that.
Really? They're mixing up meters and feet?
I mean, no, I meant meters. Sorry, meters.
Good. I'd be disappointed in your teacher if he made you do that. But okay, go ahead.
And then when he it's not a tree, sorry, it's a light post. And when he stands 4 meters from the light post, his shadow goes 4 meters in the other direction.
Okay, let me see if I can draw this picture right.
And then what is the height of the...
There's the light. He's standing 4 meters from the light post, and his shadow goes 4 meters out, right?
Right, correct.
Okay. Well, what we have is 2 similar triangles.
So how I solved it was literally I set the smaller triangle as a ratio, 2, 4, x over 8.
Correct. X comes out to be 4.
Right.
Mm-hmm.
Okay.
But it's based, you were able to set that ratio because this triangle is similar to the big triangle.
Because all the angles are the same.
Well, they both share this angle in common, and this angle is right because he stands straight up and the light pole stands straight up.
Right.
So I got 2 angles that are the same. That's all you need to prove similarity.
Right. Well, if you have 2 angles that are the same, then the third one's always going to be the same.
Exactly. So it's really angle, angle, angle. But You only need angle to prove similarity.
So let me see this one. I can't remember some of these questions. I can't. Like I just have my answers. I don't have the actual test. So,
Okay. What other kind of stuff are you covering? Maybe I can find some problems.
I messed up on graphing parabolas pretty bad.
Okay, let's give me a parabola. We'll graph it.
Oh, okay. Here. F of x equals x squared minus 6x plus 4.
Thinking for a second as to how to best answer this. First of all, I can see that that does not factor.
Right.
There's no factors of 4 that are going to add to the number of 6. Not 4 and 1, not 2 and 2. So,
right.
If I was going to try to solve the zeros of this thing, I'd have to use the quadratic. Well, there's a better way to graph a parabola. Let's talk about vertex format. If I can get this thing in this format, well, I know that H and K are my vertex.
Okay.
So I'll have a good starting spot, and then I can set y equal to 0 to find my zeros, and I'll have 3 points, and I can graph it.
Right.
The question is, how do we take any standard quadratic and put it in vertex format? Well, you do it by completing the square. It's one way.
And I think I did that. Wait. Yeah, I did do that.
Okay, good. To me, that's the easiest way to do it. The other way is using minus b over 2a. Didn't we do that last session we met?
Yeah.
In other words, if the quadratic is in standard format, which that is, as opposed to vertex format, then I can find the vertex just by solving for minus b over 2a. In fact, let's do it both ways. Well, let's do it that way for the moment. It might be easier. What is, in other words, the vertex x-coordinate, which I'm going to write like that, is equal to minus b over 2a. Well, what is that? 6 over 2. So that's 3. Got it really quick. And what's the y-coordinate of the vertex?
Plug in 3 for x.
So you have 9 minus 18 plus 4 sounds like minus 5. Now that's pretty good. That gives us 1 point. 3 minus 5, there's the vertex. I know it opens up because that thing's positive. So it's going to do something like this. I even know where the y-intercept is, right? In fact, I don't need to do anything more. The y-intercept is right there. Now, if I don't need the zeros, then I know what this point is. What is that point? This point right here is 0, 4. I know the y-intercept because it's always the constant.
Okay, so then that's going to be 3, 4?
No, 3 is right here.
Oh, 4, 4?
6.
Why is it?
It's similar. I didn't draw it quite right. This parabola is supposed to go through that point right there. Okay? So what I'm saying is the distance from here to here has got to be the same as the distance from there to there.
Okay, I see that now.
That's why it's 6, because this is 3, so that would be
Right.
6. So I now have 3 points. That's all I need to graph a parabola.
Okay.
Okay, so that was perhaps the easy way. If I want to find out what the x-intercepts are, and some teachers make you do 5 points. They always want the vertex and the x-intercepts, plus maybe 2 additional points, even though 3 points define a parabola. But let's say I wanted those 2 points in addition to the vertex. Well,
Okay.
then I've solved for the vertex. Now I set it equal to 0 and solve for these 2 points. Well, what are those points going to be? I know this does not factor, so I'm going to have to use the quadratic. So the quadratic says it's equal to 6 plus or minus the square root of 36 minus 4ac, which is 16, all over 2. So my 2 x-intercepts are, let's see, square root of 20 is 2 root 5. So my x-intercepts are 3 plus or minus root 5. This one is 3 plus root 5. This one is 3 minus root 5.
Okay. So I completed the square and I got that same answer. I got 3
Yeah,
plus or minus.
but the problem with completing the square is it's not going to give you the x-intercepts, notice.
Right.
In other words, it will give me the vertex, but then I still have to do the same amount of math to figure out 2 other points.
Wait, 3 plus or minus root 5 is the intercepts?
Uh-huh.
That's what I got as my answer, though.
Okay, well, let's complete the square. We got x squared minus 6x plus half of 6 squared plus 4, and I just added 9, so I got to subtract 9. Okay?
Okay.
So far, so good. In other words, this thing is equal to y. Haven't changed it, right?
Right.
Now I can write y is equal to x minus 3 quantity squared minus 5. My vertex has to be 3 comma minus 5.
Right.
But notice I didn't get any other points. I just got my vertex.
Then I must have done something wrong. No, I didn't. Because you set y equal to 0, and you solve.
Now you can solve. Now that I have it in this format, yeah, I can set that equal to 0 and solve for x, and I'm going to get that same thing.
Right, that's...
3 plus root 5 or 3 minus root 5.
What I did wrong is I didn't grab the vertex. I just went straight through all the way to the intercepts.
Ah. Yeah, without a doubt, the most important point on a parabola is the vertex. Probably the next 2 most important points are the x-intercepts. And you can make an argument that the next most important point after that is the y-intercept. But it's the x-intercepts and the vertex that you generally want to get. Now, notice that completing the square, to me, was not harder, I guess, than using minus b over 2a. In other words, they both got us the same information. They only got us the vertex, doing either way. Find the x-intercepts, I got to start with this, set it equal to 0, and solve it.
Right.
But to find the vertex, I have 2 choices. I can complete the square, or I can use minus b over 2a to find the x coordinate, and then substitute that in there to find the y coordinate. So I'm not sure which is easier. Maybe completing the square now that I think about it. Well, because completing the square, you get it done in one step, whereas when I used minus b over 2a, I have to take that answer and plug it back in here and solve it to get the y coordinate. So
Right.
this might be a little faster.
I also had trouble with I don't know if this is an inequality. Yeah, this was an inequality.
Okay.
It was f of x is equal to maybe it's not an inequality. It's graphing an absolute value. F of x is equal to x minus absolute value of x.
Like that?
Yeah.
Okay. This is
Okay.
not a translation of an elementary function. So I have to look at it slightly different. Okay?
Okay.
I'm going to look at it as a piecewise function. When x is greater than or equal to 0, what is f of x equal to?
If it's greater than or equal to 0, then f of x is equal to 0.
Uh-huh.
Oh, okay, yeah.
Okay.
And then if x
is less than 0,
then f of x is equal to 2.
2x.
X? Yeah. Okay.
Right? If x were, say, well, now hold on. If x were negative, then I have, let's say x were negative 4. And I would have a negative 4 minus 4, which would be minus 8, which would be 2x.
Yeah.
So, this is what we have to graph, is this piecewise function. Well, that's pretty easy. It's 0 up until the 0 point, and then it's 2x, which is just a straight line that has a slope of 2. So your graph is like that. Now notice it has that corner right there. And absolute values always have a corner.
Yeah.
In the graph.
Okay.
Typically, absolute values look something like this. Either, maybe there or up here or over here, and maybe the v is deeper.
Variable.
This is unusual because it's a combination of a polynomial and an absolute value. And so the only way I can think of to graph that is to break it into a piecewise function.
Okay.
But that works. So.
Right.
Oh, hold it. I did that wrong. I graphed it backwards.
Upside down.
Yeah. It's 0 on the right side. And it's positive 2x on the left. So that's the graph.
So wait, as y becomes smaller.
As x becomes smaller.
As x becomes smaller, f of x decreases?
The absolute value of it goes up, but its sign is negative. In other words, and whenever x is negative, our f of x is 2x. So when I am to the left of the y-axis, I need a slope of 2 on it.
Right.
And the only way to get it is to go down like that.
Okay.
And plug in some numbers. If x is minus 3, well, f of x is going to be minus 6. So yeah, it's going down.
Right.
And if x was 0, the quantity is 0. So it's actually 0 whenever x is greater than or equal to 0, and it's 2x whenever x is less than 0. So.
Right.
All right. That's a different one than I'm used to seeing. Usually when they're having you plot absolute values, you're plotting something like, x minus 3.
Yeah, my teacher likes to give us, he likes to teach us in class the very simple stuff, and then give us the most outrageous questions on the test.
Anything like this is merely a translation of the elementary function y equals absolute value of x. Well, I know how that graphs. That graphs like this. So I have to take this graph and I have to move it 3 units to the right and 2 units up. So the graph of the function...
It'll have a slope of 1 and -1, right?
Right, but I don't even need to know that. I just need to know what the elementary function looks like. And then there's no changing of shape going on here. This merely says move it 3 units to the right. This says move it 2 units up. Don't change its shape. So I'm just going to copy whatever my elementary function is, which has a slope of +1 and -1, and just move it right and up. But the problem you gave me is not a translation of an elementary function. So we can't do it that way.
Different kind of problem.
Yeah, you kind of have to do it as a piecewise. And that's the typical way you handle absolute value. If you can't do it as a translation, is you break it up into the 2 functions that it is, depending on whether whatever's inside of there is greater than or less than 0.
Yeah. It's annoying, too, because I got that it went down like that. I just couldn't figure out, like, where.
Yeah.
I had the right idea. I just couldn't figure it out on the test.
Well, you picked up my mistake when I did it. That's good. Because I had it backwards. I had the 0 when x was less than 0, and the 2x when x was greater than 0, and it's the other way around.
Right. Okay. All right. The last thing we could do is something simple.
Okay.
Ish. I don't want to review it. So like, let's say you had the square root of 500 times 500x cubed y to the 6th.
500x cubed y to the 6th. Like that?
Yeah.
Okay. Take it one at a time. First of all, let's simplify the square root of 500.
So you know that 100 times, you know that 10 times 10 is 100, so you could pull out 10.
10 root 5 is 500.
Right.
Okay. What is the square root of x cubed?
X times the square root of x.
Okay. So I'm going to put the x in the radical sign and put an x out here. So that takes care of the x cubed. What's the square root of y to the 6th?
Y to the 3rd. Y cubed.
Y cubed, exactly. So there's your answer to your problem. And if we want to put it a little neater, I would write it like this. 10xy cubed square root of 5x.
Okay. All right.
You good to go for tonight, Max?
Yeah, I think so.
Okay. Looks like I hope you have plenty of material for Saturday and Sunday. Looks like we're doing 3 hours of tutoring. You did mean to do 2 on Saturday in a row?
Yeah, 2 in a row on Saturday.
Yeah, that's fine. I'm loving it. My Saturdays and Sundays were kind of empty before you signed up, so.
Yeah, it's just midterms are next week. So.
Yeah, no, everybody does, for sure. I was surprised I was empty, because you can see how busy I was the whole week, and next week will be worse. Because everybody has their midterms next week.
Yeah, so on Saturday we'll take to go over like everything that could possibly be on the test.
Okay.
And then I guess I'll like do some problems. Like during that session, I'll do some problems, and you can help me through them.
Is your teacher going to give you a review material?
Nope.
Really?
Really.
Where are you going to get all the problems we're going to work on for 3 hours?
Well, I know that it's going to be whatever was just on this test. plus all the mixture problems.
Okay. I'm still not clear what you mean by mixture.
Like what we did with the alcohol.
Oh, that's what you mean by mixture problem.
Yeah, like chemical mixture problems.
Yeah, now I get it. I kept
Right.
thinking you meant a mixture of algebra and trig or something like
Oh, yeah, no.
combination of different math disciplines. Oh, you meant
No.
solutions. Yeah. Okay.
Yeah.
Yeah.
And then if we still need Sunday, we'll still do Sunday. If
Okay.
and we could just use it as like a review.
Works for me. And
Okay.
these are Denver times here. So it's 10
Right.
a.m.
So it'll be,
my time on Saturday, which is noon for you.
right.
I will talk to you then.
All right.
All right, Max. Bye-bye.